Hi, today I'm going to start to talk about how to use the Oceanlyz, and this video is particularly speak about the version 1.5 or earlier version. It's going to be different video show how to use the newer version 2.0 or the new version. Anyway, if you are using the 1.5 version, this is how uh, this video shows how to use that. So you can download the Oceanlyz. Come here, either you can download from download.com or you can just download it directly from here. It's a zip file. Either if you download it from either of these sources, it will give you a zip file and you can uh, uh, download it on your PC anywhere you want. And uh, also, there's online documentation. Just shows if you go to read the doc, there's an Oceanlyz documentation that has uh, in detail explanation how it works or how to use it. Just one thing to mention that it's essentially written for MATLAB, but it's also work on um, Octave. So if you have the MATLAB, it will work it there. If you don't have access to MATLAB, you can um, just download the. I will go show you the Octave, and also it's an alternative to MATLAB's open source free program. So it works on both of these programs, MATLAB or Octave. And also there are the playlist on my channel, on my YouTube channel, that has a couple of videos, including these ones that um, explain some of the basics about the theory behind how we are calculating the wave data. After you download the Oceanlyz either from download.com or directly from here, it's going to be a zip file and you need to um, unzip it anywhere on your computer. After you unzip it, here I unzip it on my C drive, Oceanlyz drive, and after you unzip it, these are what you will see inside. So it's a folder, the document folder that has the PDF document in that. Is the functions that are the functions that Oceanlyz use for calculation. There are some sample data in the sample folder, so you can use them in case you don't have a sample data or you want a data to play with that. And uh, the main two functions that you only gonna use are these two files. So you don't need any of anything inside any of those folders. The only thing that you need to work is these two, and the Oceanlyz input file. Um, in that file, you set up all the inputs or all the parameters that Oceanlyz is gonna use, and then you just run this file. You don't need to set anything inside this file. You just run it and it will run the Oceanlyz. So let's look at this one. I will go through all the parameters inside this one to show you how to what each of them means. So when you open the Oceanlyz input file, this is what you are gonna get, and then if you roll out on the very first section, it asks you where your input file. So what's the name of your input files? What's the location of your input files? And we can have it in any location or any format. So here is I have it in the math format, but you can have it in any other format, and I will show you later. So that's the single vector file. If you have it as a CSV file or any other format, make sure that's the single column file. So it's not going to be a row file or multiple column file. So it should be a single column file. So if I go in, this is the Octave, so I will go there in the sample files. So this is the file I'm using. Just open it and you will see that if I open that, it's a single column file. So this file has 5 pairs of data, and all the data goes one after another, so there is no gap between all the data. So it's one column data. So you have to have all the data, no matter what no matter what type of input file you are using. Make sure it's gonna be a single column file. Um, so let's go back here. So it's you set up your input file, and there where is that input file located, and then here it asks you, do you want to save the output or not. If you put it off, so it doesn't save the output. If you put it on, it will save the output on this location, the location that you um, um, giving to that. And the output file is going to be and I will show later, but it's going to be a structure array called name.mat. So it's going to be an structure array, and it has some fields in it. For example, um, if we want to have the wave period, the wave period is going to be wave.tp. So basically it's a peak period. And I will show you when I run it how to get to those data. So after we set up where also these are the input and then the output, here are the parameters we are going to use. The very first one is the analysis method. What method you want to use? It's going to be either a spectral or it's going to be zero crossing. If you want to do the spectral analysis using the power spectrum, so you use the spectral. You want to zero crossing method, you use this one, depending on which one you prefer. Then you have the wave calc method. If you want the wave properties to be calculated, you set it on. But if you don't want the wave properties calculated, you just set it on off. And what's the case that you might not want the wave properties to calculate is that assume you have the water depths measured by pressure sensor, and as I explained in another video, you can watch it, is that when you measure the pressure, when you measure the water depth by pressure sensor, you will lose some energy in the water depth as you move into the water depth. If you want to just correct the water depth and you don't want the wave properties, just set it at off. Otherwise, in almost most cases, if you want to calculate the wave properties, so set it on. So the only way that you set it on off is that you measure the water depth with pressure sensor and you want to correct that data without any wave calculations. Don't set it on off. Otherwise, leave it on. I would say that probably most of the cases, or you will leave it on. The next part is the number of pairs you have in your data set. And so for example, here, as I show you, I have 5 pairs of data in my data set here that I have, and the total number of data I have is 51,200 data points. So it contains 5 sets of data, so 5 bursts of measurement, but they sit one after another. So I have 5 bursts of data. So it tells how many bursts of data I have in my data set. And then it asks what's the duration of each burst in my data set. So in very simple format is that assume I measured the data for 5 hours, and then I want to analyze every hour of the data separately. So I would say that I have 5 bursts. So it means that I have 5 1-hour data set, and and for example the duration, then it would be 1 hour in that case. Here my data set is 5 bursts, and each of the bursts has about 70 minutes of data in that. And basically how it was measured, it was like that. At the beginning of every hour, our sensors measured data for 24 seconds, and after that it goes to sleep, and at the start of the next hour it wake up and measure for 24 seconds, then it goes back to sleep. At the start of the third hour it wakes up, measure for 24 seconds, and it's done it for until the 5 hours. So we have 5 hours of data, but it's not continuously measured. We have only 24 seconds of each data set, in every hour. Anyway, so depending on what you have, so number of pairs, it means that how many sections data you have in your data to be analyzed, and what's the duration of each section in your data. Automatically the Oceanlyz go ahead and grab one section after one another section. So it comes here and grab the first segment of data, analyze it, then it goes to the second, it goes to the third one, and in this case that I tell him I have 5 pairs, so it goes until the 5 segments. So it gets first segment, second segment, until the 5th segment, and analyze it. Uh, Here we set the sampling frequency, so what frequency you um, measure sampling frequency, and then here only if you measure the data with the pressure sensor. Most of the time we put the pressure sensor uh, somewhere beneath the water, on top of the water surface. So we need to set up, okay, what's the height of the pressure sensor from the bed. I have another video here about how the burst measurement and continuous measurement. You can look into those videos just to get some idea what's the burst of the data and what's the duration of each burst, for more information. And then you can here set the number of FFT. Basically, the number of FFT is it only used for spectral analysis, and it tells the Oceanlyz how many data points you want to have in your spectrum. The more data points you have is going to gives you the smoother spectrum. Otherwise, it doesn't have much effect on on the results. Just make sure that whatever number you're choosing is not going to be larger than number of data points in each burst. So in if you have, for example, 1000 data points in one burst of data, so make sure it's less than or equal than 1000. Otherwise you can play with that. It just makes your spectrum smoother or rougher. It doesn't do anything else. In most cases, if you leave it for 256, that would be, I would say, probably for all cases, for most cases, if not all cases, 256 would be enough. Here it tells your Oceanlyz if to separate sea and swell waves or not. In very quick term is the swell waves, that if, for example, you have the area that there are some waves coming out of that area and they are not locally generated, there are swells. For example, if you're looking at Gulf of Mexico, and then you have the waves coming from outside the Gulf of Mexico from the ocean. So the waves generated inside the Gulf are locally generated. The wave comes from outside the Gulf from the ocean is going to be swell waves. They are not locally generated. So it tells you in case that you need to separate the locally generated wave from the wave that comes from the outside area. If you don't have that, you just leave it off. If you have it, you can turn it on. And it here, these two define the range that your define the frequency that your swell is gonna be. So if you leave this off, you don't need to set these two. You need them only if you set this on. And then you have to set the range in case that you make sure it's not gonna choose the local generated as a swell. So that's the range you will give them. This part again, if you do the measurement with the pressure sensor, this part is going to be important. If you don't do any measurement with pressure sensor, you don't need to be worried about this part. I have another video that explains how to calculate the wave data from pressure sensor. You may want to look into that before see what are these data are. But in short, it's like that. If you measure the pressure data, if you measure the water depth with the pressure sensor, the problem is that the energy dissipate in the water depth. So when we put the pressure sensor 1 meter or 2 meter or somewhere beneath the water, some of the energy from the surface wave will be dissipated, it will vanish before it reach the sensor. So whatever the sensor reads is less than actual energy on the surface, and because of that we have to compensate for the energy loss in the water column. So this is how we do that. So we need this area only. We measure the pressure. We use the pressure to measure data. And remember, if we have the if you use a pressure sensor to measure the input should be water depths. Remember, the input data should be water depths, because we need the water depths for compensate for the energy loss, to calculate that energy loss. So it cannot be the water surface elevation, it should be the water depth. Before I explain these two, let's first look at these two. Basically, these two shows that what's the range what's the range of frequency we are gonna correct the pressure in those frequency. Um, Most of the time in the explain in that video, but most of the time is that if we are in the very low frequency, we don't need to correct them. At the very high frequency, if we correct the very high frequency, it causes the overestimation, because it artificially um, because it goes to infinity, and artificially make the large value. So we have to limit the range that we are correcting the pressure read by pressure sensor, and these two values set the limitation. What are the limitation, what are the frequency range we are applying, we are compensating the energy loss in our spectrum. Now let's go back to here. I said the this the pressure attenuation vector says if you set it on off, is that if you don't measure data with the pressure sensor, just leave it off. So if you don't want if the data is not measured by pressure sensor, just set it as off, so it's not going to compensate for energy loss during the measurement. But if you do measure the data with the pressure sensor, you have to use either on or all. If you use the pressure attenuation is equal to on, is that it only applied within this range. After that values, when for the frequency after that, it doesn't do anything. You just leave it as it is. If you use this equal to all, it first apply the pressure correction within this range, from this range to this range, and after that, for frequency larger than that, use whatever value it has for that, so it become constant after that. So it first applied, and before I saying that the pressure correction is not constant, it depends on the frequency. So it start from the F mean and apply the pressure and start to correct the pressure values until it reach to that data point. And when it reaches to that data point, it keep the constant correction after that. So one more time, what's the difference between on or all? If it is on, it apply pressure correction from F min to F max. It doesn't do anything after that. If it is all, first it applies pressure correction from F min to F max, and then after F max, it just keep the correction as a constant value. And if it, I would say I would always use this if I measure the pressure sensor to measure data. I would use all, unless I have really good reason not to do that. Otherwise, I would always use this one for the calculation. Then here, the next section, the next two sections, that it says do you want to mean cutoff or max cutoff to be turned on or turned off. When we measure the data and we do the spectral, and these are for spectral analysis, so both of these are for spectral analysis. When we are doing the spectral analysis, it's very important that most of the time the lower part of the spectrum and the higher part of the spectrum are noises, and we don't want to keep them, so we will most of them remove them from measurement. To do that, we will come here and say, okay, minimum cutoff means that yes, if there is anything less than f min, just remove it from the dataset if it is on. And if the max cutoff is on, it means that anything is above f max, just remove it from dataset. And it's good practice if you know that there's a noise in the lower range of your spectrum or higher range of your spectrum, you want to remove it, so you can set them here to remove them. If you don't want to do that, just set it as off. So either of them, if you set it as off, it doesn't remove any data. The next section, and again this one also used in a spectral analysis, is that sometimes we have our higher range of the spectrum, which is the tail of the spectrum. Um, uh, the data might be not good, might be contaminated, might be noise. For any reason, the data might not be acceptable at the tail of the spectrum. And if it is, we can go ahead and replace that tail of the spectrum with one of the empirical spectrum that we know that. If we leave it off, so I would say that always leave it off unless you have a reason to do that. If we turn it on, if you want to say that, we have to say which spectrum we want to use to replace the tail of the one. We can use the John swap or TMA. The John swap most of the time is good if we are dealing with the deep water, and the TMA spectrum is when we are dealing with the shallow or transient water. So it said which tail of these two are the empirical spectrum. Just tell us, do you want to replace the spectrum from measurement with one of these two empirical spectrum? And if we set it to one of these two, then we'll have to say from what frequency you want to replace the tail. So it tells that any frequency is larger than this value should be replaced with either of the John swap or TMA. And then also this one tells the slope of the tail and what slope we want to use to when you use the John swap or TMA. Most of the times, remember that tail is equal to -5 is for deep water, and then is for -6 is for the shallow water, and somewhere in between is going to be the transient. So basically it's just the slope of the tail. And then the very last one is that the study said, do you want to show the plot when it's doing the calculation? It can show you the plot. If you set it off, it doesn't show you anything. If you leave it on, it keeps showing the result when it's actually doing the calculation. Okay, after you set up all these value in this file and save it, what else you need to just come here in whatever folder you have, go to the folder that you have the Oceanlyz, and just run this file. So all I need to do is just run this file. If I go ahead and run that file, it starts to do the calculation for you. So it will start to do the calculation, and it will show you the progress, and also beneath that it shows the spectrum is calculated. So it's 100% done, and it shows the, okay, because we set it to be a spectral analysis. So these are the spectrum for, as I said, we have 5 years of data, and so 5 spectrum calculated here. If you go to the menu here, and you will see that it start to explain you what it is done. So here is one of the things, make sure always read that calculation method. It tells you what method is using in calculation, and if the method is using is not correct, make sure you go back and correct the values in Oceanlyz input until you get the correct one. So in this case, if you will see that because I was setting the spectral analysis and set the pressure attenuation on, it assumed that, okay, this is water depth data from the pressure sensor, because I asked them to here at this point. Let me show you again, because here I leave the pressure attenuation on. uh, it will because I let the pressure attenuation on it, it will assume that okay, this is a data measure pressure sensor. One other thing I forgot to talk about is this one. This one is that you want this value, the Fmax, automatically uh, um, calculated by Oceanlyz, or do you want you defined by user? If you leave it on, and I would do that, it will go for each burst of data. It will calculate the location of that or the value for Fmax be corrected. If you leave it off, it always use this value in all the cases. So I would leave it on. Also, one other thing before going back for the tail that I was talking about, I have also another video that explains this tail thing, so you can watch that video in case that you want. Anyway, so if I go back here, what it says, it explains based on my input, this is what I want to do, and because I leave the uh, this one, the wave calculation on, and the pressure data, so it's going to calculate the wave for me. So make sure you read this part and make sure it's doing exactly what you want. Then after that, it goes from burst by burst, and display the values it calculated in each of these bursts. And you can see the value for example burst one, so the any of them. So these are the moment of a spectrum. So this also is the wave height, the 0 moment wave height, and the peak frequency, peak period here. So it printed out for all the bursts that we have 5 bursts here, and at the end it explained all the data, and this is what I'm going to show you, is going to be saved in the wave array, and it's going to be a structure array. And everything would be obtained by the dot in the. Also, you can use this command, the field names and the wave, to get that. And for example, if I come here and you do that, it will give you all the fields that are inside that wave. So now I'm going to show, for example, some of them. Assume one of the field name is the HM, or the 0 moment wave height. So I would say I can name it anything, but I just, for the sake of name it the same. So it's going to be wave.hm. So if I want to access this one, so there's a wave dot and then this one, and then I can plot it, and it will plot the HM. So I have 5 bursts of data, and these are my wave height here. The same I can do it for example, peak period is going to be the wave, and here I have it, the name of that is .tp, and then I can plot TP again. It's going to be 5 bursts of data, 5 data points, and it's going to be my peak period. The other two I have, for example, frequency and the spectrum, and these are, each burst of data is going to be one row of data. So I will show you here, for example, if I put f is wave dot f, and you can see it here, it has a size of 5, but that's the length of that. So each burst of data is in one row. So the first row has the for the first burst, the second row data for the second, and so on. The same for the spectrum. That's its name is SYY, so it's put it here, the same. And it has, again, it has also 5 row of data. And if I want to plot it, because it's a spectrum, it's better to do it in the log format, but you can plot it either. So I will first plot the first row. Assume I want to plot for the first row, so it's going to be the first row of data. So if I plot it, it gives me, so it's the frequency and my spectrum values. In most cases, again, it's much, my case, it's easier to see what's happening if you plotted in the logarithmic scale. So if we do that, so this is our spectrum, so this is the frequency, and these are the spectrum values. So you can also here you will see that the data are saved in the wave.mat because we left this in the input file. We say to save the output. If you leave it off, so it doesn't do that, but since it's on, also it save the data here in the output destination that we give it for that. So this is how we can set up the Oceanlyz and run it. So one more time, so all we need to do is just come here. We have two files here. In the first one, you set up all the inputs and then just run the second file, and it will calculate like here and give you all the wave properties you need for your calculation. One last point is that if we are using the Oceanlyz with MATLAB, if you use it for signal processing, if you use the spectral analysis, then you need to have access to signal processing toolbox. If you are doing the zero crossing, you don't need the signal processing toolbox. The same if you are using the Octave. If you are doing this spectral analysis, you need to have the signal package installed. If you do the zero crossing, you don't need the signal package. For the MATLAB is that if you have the license for that, it's already there. Whenever you open the MATLAB, it will be loaded. For the Octave, it's free. It's included in the Octave, but it's not automatically loaded. So before you're running the Oceanlyz, you need to go there and just load it as just say right package load signal, and then it will load the signal package, and then you can do that. Again, you need the signal package either in Octave or MATLAB if we are doing the spectral analysis. If we do the zero crossing analysis, we don't need either. We don't need the signal package.